3. Wire resistors. As the name suggests, the electrical resistance of a coil is created by winding long resistance wires around a core, which is usually a ceramic or plastic coating on the wires wrapped around the core. They pull so that the wires inside are not damaged. Brick resistance is also one of the types of fixed resistance that is placed inside the ceramic cover to withstand high powers and is filled with a special type of insulation under these ceramic covers. These resistors are available in the market from 1 watt to dozens of watts.
The important thing about brick resistors is that they may get very hot during operation, and a suitable place for their installation should be considered in the circuit design. Since the wire used in the coil resistors is coiled, the property of self-conductivity is created. In this way, in addition to resistance, there is also inductance. This inductance causes phase shift, especially in larger resistances, in AC circuits and at high frequencies. Therefore, the total impedance, Z, is the sum of the apparent DC resistance and the series inductance. Impedance, Z, is the combination of the effects of resistance, R, and inductance, X, in series with it in an AC circuit.
Wire resistances have different values, from 100 ohms to 100 kilo ohms, due to flexibility in the thickness of the metal wire used and the number of possible turns of the insulation. Also, these types of resistors have a very small error, and for this reason, they are very suitable for measuring circuits and using them in the Wheatstone bridge. Coil resistors can withstand much higher electrical currents than other resistors.
Wire-wound resistances are indicated by the prefix WH or W. For example, WH10 ohms, and are available in 2 types of aluminum coating, with tolerance 1%, 2%, 5% and 10%, and glass glaze, 1%, 2% and 5%.
To support me, subscribe to my channel. Like my videos. Press the bell button for notifications. Subscribe to my channel for new videos. Share my videos. Write me a comment. Thank you.